In dynamics and statics, several types of force can be considered applicable to a body. Weight means the force due to the action of gravity, with which the Earth attracts you and in the direction of its center, and is represented as a vertical vector. You can always calculate the weight of something if you multiply its mass in kilograms by gravity, which is an approximate acceleration of 9.8 meters per second squared for our planet. Normal force is the force exerted by a surface on an object that is supported by it. The normal force acts perpendicular to the contact surface. There the object is at rest, and in this interaction, the weight and the contact force are the only ones that act in an opposite way and of equal magnitude. But if we tilt the surface, the normal force decreases while the weight remains constant. The applied force is the force that an object or a human being transfers to another body. The applied force always acts directly on the body. This is the type used when kicking a ball or pushing a box, for example. Tension is characterized by being able to transmit a force between different bodies, and that is generated when two opposing forces pull a body in opposite directions without actually breaking it. The tension force is that force that allows us to leave suspended bodies, or use pulleys to move objects. When there is an object suspended by a cable, the weight and tension have the same magnitude, but in the opposite direction. So just by calculating the weight of the object, we can know the value of the tension, since it will have the same magnitude. In the case of two suspended bodies, the system will move in the direction of the greater weight. As the weight of the Hulk is greater than the weight of the Spider-Man, the Spider-Man goes up while the Hulk goes down. The tension in the rope must be greater than its weight so that it goes up, and on the Hulk's side the tension is less than the weight and it will go down. Taking into account that the system is connected and is not elastic, the acceleration will be the same throughout the system as is the tension in the string. Friction is the type of force that occurs when a body slides over a surface or attempts to do so. Frictional forces never help movement, which means they oppose it. The friction force between two bodies is proportional to the normal force exerted by one body on the other, and does not depend on the contact area or the speed at which the bodies slide. It depends on the nature of their materials. It is an effect of the surfaces that, although they appear smooth, microscopically present roughness that hinders the movement of one over the other. Additionally, atomic interactions occur exerting forces between the materials. This force depending not only on the roughness or smoothness of the surfaces in contact. It is basically a passive force that tries to slow or even prevent the movement of the body regardless of the direction taken. There are two types of friction force: static and dynamic. The static friction force is the one that establishes the minimum force necessary to move a body. This force should be equal to that of the surface with which the two bodies involved in the movement have contact. For this reason, it is more difficult to start moving an object than to keep it moving. The friction force plays a fundamental role in daily life. With regard to static friction, it is a very useful force, since it is the one that allows humans to walk as they do, exerting friction between the shoes and the ground. It is also the one that allows the action of holding objects with hands, among many other examples. In general, the static coefficients of friction will be higher than the dynamic ones. The dynamic friction force is the force required for the motion of two interacting bodies to be uniform, always opposing the movement of the body. Ice skates create dynamic friction. Without this force, transport on wheels as it is known today would not exist. It is also the force that allows any body in motion to stop. The force of friction or friction can be obtained if we know the normal force, multiplying it by the coefficient of friction, whether static or dynamic, related to the materials in contact, always indicating it in the opposite direction to the movement. In a case like this, where we want to move an object, it is necessary that the friction force between shoes and the ground is greater than the force applied by man to the object, and this in turn is greater than the friction force between the object and the ground, to finally be able to move it.